Okay, good evening, everyone, and welcome to this online presentation arranged by Engineers Ireland Southeast Region. Um, we have two presenters this evening who are going to present on the Dunkettle Interchange upgrade scheme, which, for anybody who doesn't know, is a €200 million road upgrade in County Cork, located in an area that contains a large number of very high-risk constraints. So, quite a challenging job. So our presenters are Brendan Meagher, who holds a degree in civil and environmental engineering and has over 20 years experience in the delivery of a broad range of civil engineering projects, working for both main contractors and local authorities in the UK and Ireland. On this project, Brendan worked as a senior resident engineer during the construction period between 2020 and 2024. The second presenter, Tony O'Donoghue, has a BSc in construction management and engineering and 15 years work experience on major civil engineering projects in Australia and Ireland, including working on the New Ross bypass here in the southeast. On Dunkettle, Tony from 2020 to 2024 worked in the role of design and certification coordinator as part of the wider quality assurance team. So just before I hand over to Tony and Brendan, just to say, if you have any questions, please put them into the Q&A box and the lads will deal with them at the end. So Tony, Brendan, over to you guys.
Thank you very much, Richard, for that introduction. And thank you as well to Sinead, Brian and Stephen in Engineers Ireland Southeast Region for organising this presentation this afternoon. Myself and Tony are going to, I hope you're all able to see our screens, by the way, but myself and Tony are going to take you briefly through. In the first instance, I'll give you an introduction to the scheme and a bit of background on it. Talk a little bit about the advanced works and a little bit about what the project delivery. And then I'll hand over to Tony, who's going to talk to you about communications during the construction period, the traffic management during the construction period, traffic flows and project benefits and some lessons learned about the project. So here we are, Dunkettle Interchange. This is the new interchange layout. This photograph was taken in January of last year, actually, just before the opening. So just to give you a location of exactly where we are. The photograph on the left-hand side there, you can see Tivoli Docks in the background and Cork City well in the background. You can hardly make it out. And you can see that this crossroads of four major arteries is meeting right at the mouth of the Jack Lynch Tunnel close to the Port of Cork. So in the background there is Loch Mahon, and that is the main port artery in and out of the port facilities inside the city, and Tivoli Docks also in the background. So here we have the situation. This is an aerial view from pre-construction work, so it is around 2018 or so. So you can see the four main arteries that are meeting here. You've got the N8, which is taking the traffic in the Lower Glanmire Road towards the city. To the west side there, you've got the M8, which is the main artery coming from Dublin, connecting Dublin to Cork City. You've got the N25 going east-west, connecting all the large towns and villages in the east of the county, so Middleton and Carrigtwohill and Glounthaune and Youghal and these places, and then on up into connecting Waterford into Cork, into County Cork also. And then to the south of the roundabout, we had the N40 going through the Jack Lynch Tunnel onto the ring road around the city, and eventually connecting on to the N22, which heads west towards Macroom and eventually on to Clarny and County Kerry. So there has been major road construction going on here for a considerable amount of time, really, dating back to the early 90s. This aerial photograph you can see in front of you was taken not by a drone but by a helicopter back in 1992, just after the completion of the Glanmire bypass. Now you can see the roundabout, no sign yet of the N25 overpass or the Jack Lynch Tunnel. They were to come later, but you can see allowances have been made within the construction of the roundabout and the Glamorgan bypass, etc., for future overpasses. So this is an aerial view from 1995. Then, so you can see. I'm not sure if my mouse can be seen on screen when I'm pointing. Maybe it can't, but you can see this white kind of coloured section of road running east to west through the photograph. That is the Glamorgan bypass under construction at the time, around 1994, 95. No sign of the tunnel yet, but in the bottom left-hand corner of the screen, you can see the construction of the cofferdam or the casting basin for the concrete tunnel segments for the Jack Lynch tunnel under construction there. And this photograph here was taken sometime around, I think 1997 or so, 1998, where the tunnel segments were floated into position and sank in their final resting places to form the Jack Lynch tunnel. And the tunnel, you can see this is the northern mouth of the tunnel at the Dunkettle Interchange on the right hand side. So this eventually opened in May 1999. So that's a little bit of history and background of the area. So this is what we're faced with, I suppose. You can see the M8 traffic from the north queued to the roundabout into this as far as the eye can see. You can see the coming from the east on the right side of the photograph. This is the N25 off slip. This is the traffic heading towards the Jack Lynch tunnel, or the traffic wanting to go to Dublin, again queuing back up the slip. On the bottom left-hand corner, well, not quite the bottom left-hand corner, but the north of the N25 on the left, you can see again queuing traffic coming into the roundabout. So, and then the grade separated N25 running over the top, running free flow. So there is the problem. Sometimes exacerbated by things like this, which is an overheight vehicle entering or trying to at least enter the Jack Lynch tunnel. Again, with the systems in place prior to the interchange being constructed, this type of vehicle is picked up very late as about to enter the tunnel, and it causes a backup until the vehicle is removed. But the future design will accommodate shuttling these vehicles out of the system at an earlier opportunity. Okay, so again, just to show you again the problem, 130,000 vehicles a day approximately going through the system here. The first photograph on the left is shall I say, the N25 off slip. It's a westbound off slip. So the lane on the right side here is trying to get to Dublin, with a few people within that lane trying to skip the lights at the top and head to the tunnel as well. We've got two lanes here then, both trying to get to Dublin, or sorry, pardon me, both trying to get to N40 into the tunnel, and also a regional road coming out of Little Island, again at the traffic lights here to get onto the slip road. Along this slip here, you would have gone through two sets of traffic lights, in fact, three sets of traffic lights before you exited out into the tunnel. If you're going to Dublin, you would have gone through, I think it was four sets of traffic lights before you actually get to Dublin. This was a southbound Dublin traffic, trying to get to the N40, to the city, trying to get to head east into Middleton as well, again backed up. On the right hand side here, again, this is the N40 northbound approach towards the tunnel, again backed up through the tunnel because of the signalised structure roundabout at the old interchange. Something to keep in mind here as well is that the peak travel periods lasted for about 2 hours and 40 minutes in the mornings and the evening through the interchange, and with the interventions that we've brought about, this peak period has been reduced down to about 1.5 hours. So the interventions are proven to be a great success at this point. So, okay, and that's just that slide showing the new interchange. And this is a bit of a timeline as to when everything came about. TII or the NRA have been looking at improvements here for many a year, but the work on the design upgrade finally commenced in 2010, and motorway orders in 2012. followed on by a board planning permission and notice to treat issued in 13, and a technical advisor, Jacobs, were appointed in 2016. So then in 2018, some physical work started with with the advanced works contracts on the ground. So the de-risking activity started in 2018 to 2020. The main works delivered by John Sisk and Sons Limited started in 2020, October 2020, and was finally completed and opening ceremony there in February 2024. So just a note on who's involved in the project. So the sponsoring agency is Transport Infrastructure Ireland. The technical advisor is Jacobs. The main contract for both the advanced works actually and for the main works was John Sisk and Sons Limited. And the designer was Phoebe Tinley with Clanvillan Civil Consulting together with Rambon. So some constraints for the area. So obviously you've got the four main arteries. So the junctions are going up in these dark colour red circles. The colour probably wasn't the most appropriate, but we have four existing junctions also. We've got a junction coming out of Glanmire, Glounthaune, onto the M8 southbound. There was an on-off junction for the N25 eastbound in and out of Glanmire, Glounthaune Road. There was also a signalised junction on and off into Little Island, the regional road R634. And we had an off-slip also at the Little Island past the tunnel management building. Also have the east-west Irish Rail Cork to Middleton railway line passing the works. We also have a number of intertidal ponds, and you can see here outlined in blue, one of them. We have the Jacklin's Tunnel, and of course we have Loch Mahon. So this photograph also kind of demonstrates well, other than the physical constraints I just spoke about. In the background, you can see Little Island has a lot of pharmaceutical industries and other industries as well, and of course a major stakeholder as well in the works. Dust and vibration, etc. Of course, during the works can have a major impact on this stakeholder. Actually, I'll just go back to that slide just for a minute. Just interestingly, I was trying to count all the lanes in one cross-section of the job here earlier, and I think I counted 13 lanes in one cross-section of the job. Not that we have 13 lanes of motorway or anything, but as you can see, it's a very busy interchange. So this is the Cork-Middleton railway line and the construction of a new bridge linking the M80 and 25 over it. We have the Dunkettle Tunnel. And then I suppose we'll come to the proposed solution. This kind of spaghetti junction looking blue lines are all the new links, the new structures. So this consisted of, so we have four new roundabouts as part of the construction, a new grade separated junction to the east, which will link Glounthaune to the north with Little Island on the south, and also facilitate traffic to get access to the links going to Dublin, into the city, and west as well as east. There is then approximately 10 kilometres of link roads built, connecting every movement from the N25, N40, M8, N8, and the regional roads. So in all, I think there's about 35 individual movements you can make here. So just a finished product showing the new grade separate junction to the east, and accommodating the N25 east and westbound, accommodating the N40 off slip and the M8 westbound off slip also, as well as access into Little Island. And you can see here also some of the ITS or intelligent transport systems that were installed as part of the project. You can see the VMS boards installed at the top of the ramps near the west or the south side of the left hand side of the picture, at least, near the structure there. So these were some of the overviews that would have been included in the newsletters issue, which Tony will talk a little bit more about later. But these were some of the movements that, like if a new link opened, this is how we would describe it in the newsletter. So our biggest stakeholder, the travelling public, could see the new movement. For example, here, this is the N40 to N25 link. So previously you would have come in onto the roundabout and gone through 3 sets of traffic lights before exiting the slip lane onto the N25 and heading east. This is now a free flow movement right through the interchange. Example of a southbound movement, the M8. So again, you would have previously had to queue in traffic to get onto the roundabout. Wait at the traffic lights, wait your turn, and then turn east and head off up the link onto the N25. This was a pictorial graphic of how we explained it in the newsletter as well, showing the movements to move road users. So that's a little bit of background on the project. So just to talk a little bit about the advanced works. As I said earlier, the advanced works commenced in 2018 to 2020, and really they were designed to kind of eliminate a lot of the risky activities, or the activities which would put the main project at risk. For example, major utilities which need to be diverted. We also then looked at taking pedestrians and cyclists as much as we could possibly out of the system. We looked at approach capacity improvements, again trying to take some traffic volume out of the system during the construction, and also looked at a lot of site investigation works. So this here is an example of one of the major services which was diverted in the advanced works to de-risk the main works. This is a 1200mm diameter Irish water main passing under the N25, coming from the north of the N25 to the south of the N25. This was diverted to a lower level to accommodate one of the new link roads and to accommodate a structure that had to be constructed at that location. Again, one of the things we did during the advanced works was to prepare a good as-built of all the services in the location. As you can imagine, it's a very busy area. We have got ESB, we've got transmission gas mains, we've got large diameter water mains. Every telecommunications company passes through here, ENET passes through here, and then we've got also a lot of the TII telecommunication systems here as well. You can see here this graphic in front of you here is just displaying a geophysical exercise that we completed at the junction, showing all the services at the junction. It's scaled out massively, but yeah, we had a multitude of services in the location. Site investigations also, there was a lot of site investigations undertaken as part of the advanced works. The idea being that when the main contractor came to site with his designer, that site investigation works are completed to allow the design to commence as quickly as possible. So site investigations were designed by the contractor and their designer together with the site team. So around structures, around new structures, boreholes and trial holes were undertaken. When new embankment construction had to commence, with boreholes and trial holes undertaken also. So here we're looking at some of the footway and cycleway construction works that were commenced during the advanced works also. So the photograph on the left-hand side is a photograph of the new pedestrian cycleway facility that was constructed linking the Lower Glanmire Road to the Glantown Road, again with the view of taking cyclists and out of the system for the construction works and permanently as well. Also on the right hand side is a photograph of the Breweries Bridge and cycle lane bridge over the Irish Rail Bridge that was constructed. Again, during the advanced works, this was constructed and linked up early during the construction works with the new shared facility linking Glantown to Little Island. So then on the approach capacity improvements, the top left-hand corner there, you can see the link road linking the N25 traffic travelling eastbound and want to go to Dublin. So the link road was constructed during the advance works, which left the bridge widening to be completed early in the main works, which then took that traffic movement out of the main interchange for the duration of the construction works. Again, on the right hand side here, this was the traffic. This is what we call Link T, which is linking really the traffic who want to go eastbound on the N25 and head towards Glounthaune or into Carrigtwohill on the Glounthaune Road. So this road was constructed early doors as well, again taking that traffic movement as best as possible out of the main interchange. The photograph on the bottom of the page there, again, this is the regional road, the R634 in Little Island, and this was part of the new link road that would link Glounthaune across to Little Island. So this was built early doors as well, again, as a time-saving mechanism to get traffic out of the system early and during the main works. So here's some numbers for fun on the interchange. I might not go through them all, but suffice to say there was over 30 structures on the job, nearly 500,000 tonnes of recyclable material in the earthworks, over 20 kilometres of drainage, 70,000 tonnes of asphalt, just an idea of some of the items on it. And again, just to note that one there in the towards the middle near the bottom is 120,000 road users a day. So a little bit about project delivery. Again, I think the project delivery or the construction of the main project here could be a long presentation all by itself. So I'm going to quickly skim over the top on some of the interesting earthworks and structural aspects of the project. The shot on the left-hand side of the screen, this is just to give you an idea of the geotechnical aspects and treatments, etc. Those areas there are the intertidal ponds. So the areas in blue are ponds that were maintained, and the areas shown in orange are new sections of pond that were constructed. And the areas in red were other sections of pond that had to be infilled. So you can imagine if we're filling pond sections and constructing on top of them, intertidal mudflats, there's a challenge in that. So the area itself is located in, it's a U-shaped valley. So from the north side of the valley, which is the Glounthaune direction, over to the south side of the valley, which is heading over for the Briniskilly Sham Valley area. So this is where it's in the middle of the U-shaped valley, and we've up to 27 and 22 meters depth of alluvium in this area. We also had the challenge of the main line itself, the N25, which was previously surcharged during the construction of the N25 back in the late 90s. And then trying to tie into that and ensuring we have no differential settlement from between the new construction and the old. Again, this is just a couple of slides to demonstrate. You have Loch Mahon in the background. You have the tidal influences of Loch Mahon on the earthworks activities you're doing within the system here. You have river traffic as well, which we found did affect readings within our piezometers. You have the Jack Lynch Tunnel portal, so the boat unit of the Jack Lynch Tunnel, and again, as I said, the surcharge from previous construction here. So this drawing on the left, the scale isn't great on it, but the areas in blue, light blue that you can see, these are the first method of ground improvement, which is excavate and replace. The areas shown in light green, another method of ground improvement, which was prefabricated vertical drains or PVDs. The areas shown in that kind of orange or fawn colour. They're areas of CMCs, which is controlled modulus columns, the type of piling that was used on the project. So here's just a slide just for those who don't know what a PVD is. So on the left-hand side, you can see there we have a granular layer, which is acting as a piling platform, as well as acting as your drainage layer for your vertical drains. The excavator on the left-hand side is holding a derrick with for installation of the vertical drains. However, in some of the locations here on site, we found that there was obstructions deep below ground, so which were obstructing the installation of the PVDs. So the piling rig on the right-hand side it has a vibro hammer on it and a probe. So in advance of the PVDs being installed, the areas have to be probed to move any large obstructions out of the way. So then the sequence of construction. I'll go to my next slide, maybe it might explain it a little bit better. So the sequence of construction here, this is a cross section through one of the embankments, and on the bottom here, these dashed vertical lines, these are the PVDs. And just above that, you see a blue line and a kind of hatched area. That is your horizontal drainage material or your free draining stone, so that when the load of the embankment comes down and pushes the water out of the wick drains, the water is somewhere to drain to. And then the embankment above that is constructed in stages of about 1.5 meters at a time. So like the first 1.5 meters is constructed and allowed to settle until the pore water pressure in our telemetry is as 90% of the pore water pressure has been dissipated. This in some instances takes maybe 4 weeks or maybe a little bit longer. So this stage of construction goes on until we get to our finished construction level. And then, as you can see, that orange dashed line on top and that cross-hatched area on top of the embankment, this is a surcharged area, approximately metre deep of surcharge. And this surcharge was left on until 95% of that excess pore water pressure had dissipated. And then removed. So yeah, the progress and the timeline in these constructions can be considerable. So the other method of construction that was used for ground improvements underneath the embankments was something called CMC or controlled modulus columns. So this is very similar to CFA piling, whereby a CFA piling rig or a displacement auger actually used on a standard piling rig is used to displace the soft material underground and pump concrete back in instead. Now, these columns aren't used really as a supporting structure, more so they're used as a way of increasing the modulus of or improving the modulus of the underlying materials. So again, a cross section here through a standard embankment construction using CMCs or PVDs. So you can see here that the contractor adopted a steep and side slope construction methodology. There was a number of reasons for this. One, with normal embankment construction and 1 or 2 or 1 or 3 side slopes, we would run out of room really to accommodate a lot of the intertidal ponds, etc. Secondly, then I suppose tightening up the cross section meant that the earthworks balance in the job, which we had a negative earthworks balance, meant that the import could be less. And finally, with a narrower embankment cross section, it meant that the ground improvements or the footprint of the ground improvements could be less also. So these are just some photographs of the steep and side slopes under construction. So this is a 70-degree or 67-degree steep and side slope built in layers of about 750 mil, using temporary works formed in order to maintain the correct slope. You can see them there, the grey forms with the handrails on them. They're lifted back out and moved up a layer each time. So then these embankments are built with a reinforcing geotechnical layer every 750 mil, And along the face then, we have a Meagher mesh baskets as well. The face is then topsoil and seeded with the finished product. This is a photograph of one of the finished products, left with a nice green slope adjacent to one of the structures here in Dunkettle. This one here, this slide here is just to demonstrate as well that where we're tying into embankments, you can see the plan view on the bottom of the slide showing these are CMC improved ground improved embankments tying into existing embankments. I mentioned earlier about the difficulties with previously surcharged embankments and how we tie into them. Well, this is one of the construction methods used, which is the CMC and PVD ground improvements together with a stage construction and a surcharge layer. So now, as you can imagine, with this type of construction or earthworks construction, we would have had every conceivable method of monitoring settlement and movement. So we had our extensiometers, magnetic extensiometers, our settlement plates, top and bottom, inclinometers, etc., all constantly be monitored by the contractor and their designer. A little bit about the structures on the project. This is structure 01. This is the structure, I might just flick down for a second. This structure, which is at the new grade separated junction to the east of the main interchange. Just rolling back up again. So this structure, three-span structure, spans of approximately 24 to 29 meters in each of the spans. Built on CFA piles, approximately 20 piles at each location, at each support. The challenge with this one was, whilst the abutments could be built offline, the two central piers have to be built whilst accommodating the N25 traffic. So you can see in the photograph in the middle there, one of the central piers had to be piled in the median once maintaining that live traffic on either side, and then had to be excavated for the pile cap to be constructed. So you can see the level of effort that had to be that the main contractor had to go to in order to construct a cofferdam in live traffic in the central median to build the pile cap in that location and the main piers. And then, of course, with the construction of the deck on the bridge, this was done under road closures. So you can see there, this is the main N25, and that photograph on the right hand side closed at night while the 60-ton W9 banner are being lifted into position. There were 6 number beams on each span. So the overall length of the bridge was about 83 meters and 20 meters wide. So there's a finished product accommodating the N25 eastbound and westbound, as well as the N25 westbound off-ramp to the tunnel and the N25 westbound off-ramp to the N8. So anyone who travelled through the N25 and off the off-ramp and into the tunnel or even over the N25 during the construction period will have seen a structure sticking up by itself with no roads attached to it for about 6 months. And I got lots of questions about how you put that bridge in the wrong place, but just that the embankments hadn't been constructed yet, no one could really envisage where the link roads were going. But this bridge in itself was a major challenge. The challenges here being that it was originally a 2-span bridge with one of the central pier having to be constructed in the junction in the middle of 2 of the lanes going to the N40. The contractor, together with their designer, came up with a single span concept. So this still meant that piling and the foundation construction of the bridge had to be done under lane closures at night. So you can see that photo on the left hand side there of the piling happening at night. The photograph in the middle is the piling rig parked up during the day, and the CMC piling rig in the background piling the embankment leading up to the structure. So the span of the structure ended up being approximately a single span of 36.7 metres and an overall width of the bridge of being 11 metres. This is to accommodate the traffic from the N25 onto the M8. So here we have the finished product spanning the M8 northbound, southbound lanes and the link road from the M25 to the M40. So this is the middle of the old roundabout. There was two structures, both cast in situ decks and pre-stressed decks on them. So both of these structures had to be extended. You can see they're circled in red. The extension is shown, the new extension is shown. Both of these had to be extended to accommodate the movement coming from the N25 eastbound into the tunnel. So whilst these are actually two new structures rather than extending the existing structures, because of the old type of design of the old structure was a post-tension deck, and the new form of construction used these days with precast materials, we don't have an integrated structure here. Anyone knowing about constructing bridges or extending bridges, under bridges will know that some form of support will be required to maintain the traffic flow on the main line directly adjacent to your construction. So here you can see what we adopted here, or what the contractor and the designer adopted here, was a ground anchor system with a shotcrete reinforced concrete wall at the face. So these ground anchors, probably 180 of them per bridge, so about 360 of them in all, about 8 to 10 meters in length, and a shotcrete panelling at the front. Now that supported the upper level, and the photograph then on the right showing the sheet pile cofferdam constructed at the lower level then in order to construct the foundations on top of the pile cap. Here is just a couple of photographs depicting the piling, again in a busy area in the middle of the roundabout, next to live lanes, and on the right hand side you can see the pile test in operation. And you can see the supporting structure to the left, the temporary supporting structure to the left of the pile test. So then here we go. This is the finished product. So two of these bridges extending the N25 to allow that movement going from the N25 eastbound into the tunnel. So for some reason, this is probably the most difficult bridge on the project, and the most interesting one, but I've managed to squeeze it all down into one slide. So this probably does deserve, fairness to Siscan and their designer, this probably does deserve a presentation all of its own at some point. So this is the bridge over, we call it Structure 8, but it spans the Irish Rail line heading from Cork Middleton, and it carries the traffic going up and down the M8. So you can see, and the stage construction of this was that it's built in two halves. So the southbound bridge was built, all the traffic was diverted onto that. In the permanent case, that would only carry the southbound traffic off the M8, but the southbound was reduced to one lane and put onto that new bridge. The old bridge was then demolished during rail possessions over a period of about a week or so during Irish rail possessions, and then the new bridge constructed in over the railway line. So the phasing of this took over a year, but it probably is a presentation all of its own. Again, it was a CMC piles, standard pile caps, piles up to 20 meters long there in this location. And then you can see the finished product there. So it takes the northbound traffic and the southbound traffic on the M8, and it also takes that link coming in from the left side, that's the link coming from Middleton from the N25 heading northbound as well. I think that's all I have at the moment. I'm going to pass you over now to Tony O'Donoghue, which will take you through some of the communications, ITS systems, etc. on the project.
Thanks, Brennan. So I'll run through so communication and ITS. We're part of the Dunkettle project. So I suppose with all of the works that Brendan has described, one of our biggest challenges was to keep the travelling public up to date on the movements and the different configurations that were going to be required to keep them moving and to keep construction going as well and progressing. And basically, we were retrofitting the largest interchanges in the country and facilitating 120,000 vehicles a day. So there was a significant challenge in that. And I suppose the idea was we adopted a philosophy of no surprises as so far as possible, in that we kind of signposted or telegraphed all of the upcoming works in advance, so people could adjust their journeys if they could at all, if they had scope to change their day and whatnot, just to facilitate an easier journey and just manage the traffic as best we could. And so the aim was to provide factual information to everyone through the project communication system, so the official channels, and make the travelling public aware. And so, like I mentioned, to give them an option to assess their journey, see if they could avoid maybe a particularly disruptive phase or something that was happening on a day or a night shift and whatnot, and adjust our plans accordingly. So I suppose one benefit that we did benefit from was, with COVID-19, ongoing traffic was lighter, and in that same respect, some people would have had the option to adjust, say, days of attendance in offices and things to avoid some maybe the more disruptive traffic switches and maybe diversions and whatnot. I suppose our experience was, despite the best efforts in terms of signage and public messaging, a lot of people tend to only take notice of what you've told them when they're faced with the change. So with the best will in the world, what we experienced was there was some additional maybe traffic on the days directly following a switch or a change, and as people became familiar with their new route, the delays or disruption kind of dissipated. So our communication strategy involved the project website, a weekly newsletter distributed at 12 midday each Friday, a dedicated traffic app, social media engagement with the likes of Twitter and so on, and we had a project email address where people could issue their queries directly to us, and they'd get a specific answer to their queries. And this is just an overview of the project website. So the project website included project information, layouts of the new junction, photos of the works as they progressed, and a live camera feed. And the live camera feed is very beneficial for people, and this was equally available on the app. So people could actually, in real time, check their route prior to setting off. So say if you were working in a little island, and we were based in Little Island ourselves, we could check the traffic and see how it was immediately prior to setting off, just to adjust your journey accordingly. And the newsletter, like I mentioned, went out kind of religiously at 12 on Friday, and the idea was to give up the date information on what was happening on the project and to flag upcoming traffic switches and diversions and closures and such. And this allowed people to plan their journey best they could. And then I suppose certain media outlets, the likes of Cork and stuff, would have taken and chopped this up and made news articles out of it. So that was all beneficial, and it helped the distribution, just get the message out there as best we could. And even with the likes of the newsletter and the upgrade or the update, and the likes of, say, if one company could sign up just their one email address, but they could further distribute it to a few hundred people. So the reach was quite wide, and there was 260 newsletters across the course of the project. And so one of the highlights of the newsletter was the use and the link, YouTube link to drone footage. So it's probably one of the most, the best visual for people of upcoming works and to get a feel for what the new route will look like and how their new journey will transpire once the links are open. And I suppose this was most beneficial in July 2023. We had a single opening event of 7 link roads and simultaneously turned off the traffic lights to the existing signalised junction. So I suppose that was the biggest change of function of the junction from a signalised roundabout to a multi-link interchange. So to kind of help prepare people the best we could, we had drone footage and videos that literally flew the route as if you were driving it. So people could see and visualise their route and how it would look before the switch. And that would help to kind of alleviate any, I suppose, disruption and delays of people being unsure insofar as possible. Again, the app, people could log on and check live feed, and another benefit of the app was it had we could issue traffic updates and notifications on breakdowns and whatnot, so people could see a breakdown that might impinge on their journey. And again, the likes of this was passed on to other news outlets and whatnot who would have further distributed it. And with the app, this is kind of just an overview of how our live cameras looked. So you could check your route, and there were approximately 10,000, well over 10,000 downloads of the app. So there was a reasonable uptake of it throughout the course of the project. And with social media, I suppose Twitter or X was probably played the biggest part in it. Again, we would extract the traffic bulletins and updates of breakdowns and such, and alert people on Twitter, and then tag the likes of Cork and Red FM and whatnot, so they could further distribute message and just help get the message out there. And email communication, I suppose some of the old ways are the best, in that a lot of people are maybe most comfortable in engaging in that fashion. So they would put their queries and concerns and observations to us, and we would answer them as best we could in a timely manner, and and go and meet them if necessary, if they needed further information or to raise concerns about a particular element. So it worked well throughout the lifespan of the project. A scale model was developed as well, and that was beneficial for stakeholders and very useful for some people who would call to the office and have questions, and we could talk them through what the change would look like and how it would affect their property, their journey, or what have you. It was also very useful for schools. It would have done tours of local schools, and in the weeks prior to the large switch in July of 23, we would have visited some of the larger employers in Little Island and showed them the model with marked up roads, just so they can again visualise how their new route will look after the change. A traffic forum was established by TI and Jacobs in advance of the construction works. The initial objective was to set up a forum to engage with the emergency services, so they were fully aware of changes and the allowances made for them to transit through the junction while the works were ongoing. And the forum was independently chaired, which allowed things to run a bit smoother. And that was expanded out to include the likes of Erto, the operators of the Jack Lynch Tunnel, and Aegis, the motorway maintenance contractor responsible for this southern region. And I suppose just that coordination just helped everybody be on the same page with respect to works, and that Urto would have planned maintenance and known shutdowns, and likewise with Aegis they would have both planned and unplanned maintenance and repairs to their infrastructure immediately adjacent to our site. And again, there was fortnightly meetings with key stakeholders, including Beatrice as well. Brendan would have mentioned there that we would have had the likes of dust monitoring and noise monitoring and such immediately outside of their premises, just to give assurances that we weren't interfering with their operations. Other key stakeholders in the area would have included the likes of Irish Rail, the Bella, Leia, Cara, Beatrice, Office of Public Works, Irish Fisheries, and all the various utility providers. And the Little Island Business Association had quite a strong representation as well. And obviously, we're concerned of how disruption might affect their works in their business. A few slides on the ITS. So the ITS was, I suppose the objective is to provide information to inform people in advance of hitting any traffic of upcoming disruptions, delays, and it's also used to signal, bad weather events and such to be expected in the coming days. And it was delivered in 3 phases. So initially there was, on the N40, there was VMS structures installed prior to the Dunkettle works. They were followed by the Dunkettle Advanced Work ITS program of works, and then integrated with the Dunkettle Main Works ITS, which would have also included automatic number plate recognition cameras, high-spec CCTV, wigwags and barriers to divert the oversized vehicles away from the tunnel. We found these worked well. Again, it's just all about messaging and getting your message out to the public to forewarn them in advance of any potential disruptions. So just a quick summary on some of the engagements. So 500,000 views on the drone footage, which we found useful. And again, one of the best visuals in explaining to people of the upcoming works and the changes to be expected. I can speak now on temporary traffic management, some of the traffic flows and project benefits. So the reason for the project and how the data has proven the project to be a success, and then some lessons learned to round off. So this slide here shows a phasing drawing. So these phasing drawings were developed at planning stage, and I suppose were a precursor to the works. I suppose we had to prove that the philosophy of the construction sequence worked, and we could facilitate the 120,000 vehicle movements through the project while still delivering the project in a timely manner. So the colour coding here just shows, so for example, the pink is some of the works delivered under the advanced work. The green is like a recently opened link road, and the red is an upcoming link road which will be available. And these are especially useful for the likes of blue light services and the wider stakeholders to keep them up to date on the ever-changing kind of landscape of navigating the junction while it's being built. This particularly busy photo is, I suppose, where the markups and the visualizations come into their own. And again, so the pink indicates a new route which had been opened. So for northbound traffic from N40 exiting the Jackbridge Tunnel heading north to Dublin over phase 1 of the rail bridge that Brendan spoke of. And I suppose just immediately in the foreground you can see the CMC rig constructing the support foundation for phase 2 of that bridge. And the red is an upcoming link road, link B, which would take traffic from the west and looking to go east. So that's an upcoming link to be opened at the time of this slide was released, and then upon opening that would have allowed us to close this orange hatch section, which was the old slip, the eastbound slip. And again, you can see ongoing works to those extension, those bridges to the existing Dunkettle N25 on bridges. Again, just a flavour of how the works progressed adjacent to live traffic. I suppose this was the reality throughout the job. We had to keep a minimum of 2 lanes of traffic open, certainly through the primary junction, insofar as possible, and safely construct our works. So some retaining wall works being delivered under the protection of the varial guard barrier. And again, the picture on the right shows some embankment construction, and you can see how the works are hemmed in both sides by live traffic, and just shows sort of the restricted nature of the works and the, I suppose, restricted access and egress. So any, I suppose, fill delivery and would have had a fairly convoluted route out. I think the trucks for here would have had to exit out, go through the tunnel, up and over Mahon to go and fill again from their draw sites. Brendan would have touched on this earlier, so just some shots of some of the night works progressing on the northern approach to the tunnel. That's the structure 5 that was sticking up for quite a period, but you can see the works progressing on the departure of that bridge. So CMC and the PVD rig working simultaneously there in a very tight location. Again, in the bottom picture, you can see phase 2, that rail bridge progressing. So you've got the beams landed over 2 of the spans, columns up for the 3rd span, and the CMC rig is just finishing those foundation works. And just to touch on the demolition of the rail bridge from the point of view of maybe recycling point of view. So the rail bridge was cut into segments with the diamond coated rope lifted out under possession. You can see some of the abutments stacked here ready for crushing and recycling. And at the end of the day, this little upstand was kind of all that was left to be seen of the old bridge. Just to touch on the benefits of the project, I suppose that the reason it was all undertaken was to deliver journey time savings, reduce congestion, and basically make for a more user-friendly junction. So as just to explain, if you can see these maps, so the traffic monitoring company, when they set out day one, they established nodes basically outside of the project and measured the journey times from a set point to another set point. So for example, on the M8 node is set towards junction 18 at Knockgraha, and the N40 node is around the Frankfield area where the new the shared facility bridge is. So I suppose although the majority of that route is actually outside of our project, that was a kind of a functional journey that was measured just as a metric. And what we have measured from compared to the 2019 levels is a 14 to 16 minute savings on average across the AM and PM peaks, which is a greater than 50% saving on the journey time between those nodes. Likewise, in the reverse direction, we have a 9 to 13 minute saving, 40 to 60% of your journey time saving between those same nodes in the reverse direction, going from south to north. And on here, probably one of our busier movements through the junction, we're recording 8 to 9 minute savings versus 2019 in the AM. So it's greater than 50% reduction. And in the PM, it's approximately a 3 minute saving which is still equating to 25% journey time reduction. And I suppose one thing that's important to note, and this actually demonstrates it quite well, you can see all of the red, like most, like this is, if this is the junction, all of this is outside of the junction. So I suppose delays through the junction are often as a result to incidents, breakdowns, crashes, what have you, outside of the junction, particularly say at Bloomfield, Mahon, and further on to the Kinsale Road. And these areas tend to actually build up quite quickly back through the junction. But I suppose, as I mentioned before, these were just kind of functional movements were measured as a kind of an understandable metric. And again, just to explain how these route times were established, there was a baseline taken between the nodes. And for example, this is junction 2 here at Little Island, and again to the Frankfield node. And as I've explained, this one is up at Knockgraha. To establish a baseline, what was taken was the Google Maps journey time taken, for example, at 3 a.m. where there's next to no traffic on the road and it's in total free flow. So these were measured. So for example, in 40M8 was 10 minutes 26 seconds to undertake that journey. And if you were delayed by 30%, that is considered peak traffic. So just to give you an idea of the savings we've made through the completion of the project. So the AM peak, so when you were at 30% above your free flow journey time, that lasted for over 2 hours in the AM of 2019, and that's measured at around 30 minutes in 2023, 2024 in the AM. And likewise, the PM peak in 2019 is at approximately 2.5 hours, and we're down to 1.5 hours. So you can see, I suppose, the aggregate overall peak reduction is 58% in peak time congestion. So I suppose that kind of demonstrates the benefits of the project. And then just some collision data or incident data that was supplied to us. So we've measured the dates, while they might look a little peculiar. So the 12th of February was the opening date. So measuring from the opening date to the 31st of December of last year, there were 31 incidents, breakdowns, collisions recorded through the junction. And in a comparable period in 2019, there were 81. So I suppose it's demonstrable here that the realigned junction has led to a reduction in incidents, accidents through the area, which has to be applauded. Just a word on sustainability. So there was 135,000 tonnes of Class 1, Class 2 material imported under Article 27 licence from predominantly local residential projects in the area, from the likes of Rochestown and even closer afield as well. Typically the journey times were distances were less than 11 kilometres. And an initiative that was implemented by the contractor was to introduce HVO, and I believe that's even more widely used as time has elapsed. One particularly interesting sustainability story from the project was the use of planings from the Cork airport. So during COVID, they undertook a restoration of their main runway, and we were the beneficiaries of around 2,500 cubes of imported materials. So that was combined with natural aggregates to form 6F2 in accordance with the Series 600, and you can see that's this black material stored here, which looks somewhat out of sorts. So that was a good news story, and I suppose the reason for that is that there was around a 50% reduction in the CO2 of the material that would have been used in the construction of those embankments where the fill was used, and the potential embodied carbon saving is in the region of 46,000 CO2 ton equivalent. And then just a quick word on lessons learned. So Brendan would have touched on it. A lot of these were realised in the advanced works. So archaeology was done upfront, site investigations, quite a detailed site investigations were done upfront, and service diversions, which de-risked the project enormously. Again, following from that, the statutory consents were sought and secured. So Section 50s and the structural certificates, the TARs and the SCAs were secured as well. I suppose, by way of lessons learned in a brownfield site, I suppose what we found is that we would really recommend a full assessment of existing structures. When we delved into the details of as-built from some of the structures that were constructed back in the 90s as part of the bypasses, not all of the drawings were there, and that wasn't immediately obvious, so that led to follow-on intrusive investigations, which was, I suppose, both predominantly costly in terms of time and in scoping the investigations, getting results and whatnot. So I suppose you really do need your eyes wide open when you're dealing with existing structures. And then the early adoption of BIM, I suppose, just especially in such a congested junction as ours, I suppose the BIM is a really useful tool, and it could complement really well with the drone footage for demonstrating future movements and modifications to roads, junctions, layouts and whatnot. And the obvious one, I suppose, was clash detection, but I suppose particularly here you can see the likes of you can check your ITS structure compared to your footings, compared to your ducting, sight lines for signage with over bridges and whatnot, and so frequent you can get a good you can check those well in advance of the works. And that's just a conclusion photograph there. So I suppose just to round out, thank you to the South East branch of Engineers Ireland for allowing us the opportunity to present some of the highlights of an exciting project delivered on a very challenging brownfield site. And it's probably only the second busiest interchange in the country, next to maybe the Red Cow. And we believe that the success of the project has been founded on the collaborative relationship established, and I suppose more importantly maintained throughout the life cycle of the project between TII, CISC, Fairley, Timney, Rambach, Clendillan and Jacobs. I believe that brings us just to an overview of the opening day. So the photograph shows the ceremony on the 12th of February 24, where the project was officially opened by Antánaiste Micheál Martin, together with the Lord Mayor of Cork, Councillor Kieran McCarthy, and the Mayor of County Cork, Councillor Frank O'Flynn, with CEO of TI, Peter Walsh. And that's it from myself and Brendan.